Hello guys, today I'll show you how WAN attacks work. I'm Max Kossatz and this is an educational video only. First of all, it is very important to know that there is a difference between the exploit and the payload. For the purpose of this video, you should definitely know what the exploit is and what the payload is, and what the difference between those two is. It is very easy to just Google for exploit and payload. There are many websites which explain what these two are, and definitely also what the differences are. One example is Wikipedia, of course. To make things clear at the beginning, the SRV host is the IP on which the exploit pending service is running in the network. Excuse me, this should be a that, not a is. So if we have an exploit that runs on a website which runs on the Apache or any other web server on our attacking machine, then of course the victim has to go to the website that runs on our machine. This means that there is a URL that is handed to the victim. This URL is the public IP address of our router. As you may know, if you want to go to a website, you send a request. But you don't directly send the request to the website. You send this website request to the router. The router with its public IP address then sends the request to the web server, let's say Facebook. Facebook then replies with the answer back to your router. It can't reply to you because you don't have a public IP address, but the router does. So then the router gets the reply and then it forwards it to you again, and if you are located in its network. The same thing happens here, but it is very important that you set the SRV host to your internal IP address. Then the link you generate with, let's say, Metasploit will be a local IP address link which starts with your PC IP address, which can be found on a Windows machine with ipconfig, on a Linux with ifconfig, and here, for example, in my network, I have the network IPv4 address 192.168.2.103. Now, the link generated isn't directly sent to the victim. You send the victim the link containing the IP address of your router, the public IP address. On your router, you then forward the packages coming into your network over the specified port, which I'll talk about later, to this IP address. So here's a little picture representation of what is happening. The victim wants to see the exploit on the public IP address of our router. It asks for 168.234.12.31/exploit. This goes to the router. This is an example setting of what you should do on your router so that your attacker PC can work as the web server on which the exploit service is running. Watch out, again, this isn't for the payload, only for the website on which your exploit is running. Watch out that your IP address for the server is correct. So now it asks, is there a website running in your network? And the router says, yes. There's the MSF HTTP service running on 192.168.2.104 on port 8080. So it then sends this back to the attacker PC because this is what the settings tell it. So now there is a connection between the victim and the attacker PC. But again, it is very important that the SRV host is correct, this IP address, and the SRV port is the port on which the service is running. So here we forwarded port 8080. So the SVR port has to be 8080 as well. Now the victim found the website on which the exploit is running. This could be a Java applet, for example. As the victim basically downloads, receives the packages from the website, so it all goes back to the victim as a reply. Now the packages with the exploit are on the victim's PC. This Java applet exploit then triggers the payload that we injected into the exploit. So the exploit code triggers the payload code. Now we assume that the payload is something like the metaplater reverse TCP, which means that there is a connection again between the victim and the attacker PC. But watch out, this connection isn't to compare or is equal to the HTTP connection we built when port forwarding the last port and running the service on the HTTP Apache server. Well, I don't know if it's Apache server, but some kind of web server hosted by MSF, Metasploit. Now we come to the question that was asked. Is the SVR host and port the same values as the L host and L port? And the answer is no, it's not the same. The SVR host and port is for the HTTP connection that I just showed. But now we are working on the payload, which is set up by saying set payload and then the payload. The payload has its own options. If you just say use and then the exploit and then type in show options, it shows you the options for the exploit. If you then say set payload metapreter reverse TCP and then say again show options, there are additional options. And these additional options then say lhost and lport, since these are belonging to the payload, not the exploit. So now the lhost from the payload is the public IP from the router. So here we see the victim then receives the payload from the exploit. So it has the payload. It executes the information, the code in the payload, which says create a connection to this IP address. And of course we can't use our local IP address because we aren't public. This isn't a public IP address. We have to use the router's public IP address, which is this one. So the L host in this case would be the router's public IP. The L port is any port you want to that on which this exploit service is running. So not the, that was wrong, not the exploit but the payload service. The listener for the reverse TCP connection that the victim establishes with the attacker PC. So often port 444 is used. No, sorry, 4444 is used, 4 times 4, because that's a port that isn't used by any other service at the moment. So there is less of a chance that the other service on the PC uses this. So here we go again. The victim connects via metapreter reverse TCP to the public IP address 168.234.12.31. And of course, the router then has to have the settings to forward everything to the justified port. So if the L port to the L host is 4444, port 4444. Excuse me at this point because I just forgot what I said before, because I paused the video to make the screenshot, but the router forwards everything with the settings that is incoming on port 4444 to the IP address of the attacker PC, which of course has to be correct again. 129.168.2.104, your internal IP address in your network. Incoming 4444 going to your in the network. And there we go. Now there's a TCP connection via metapreter reverse TCP between the victim and the attacker PC. Now, as a last hint, I'll go a bit back. Remember that we opened up the 8080 port, meaning that we're running a web server on our attacker PC. What I saw on attacks which targeted me was that the attacker left this port open and left the web server running, which meant that I had a connection to the attacker's PC in the network, because of course I then can connect to the attacker PC using his router's public IP, using the open port 8080, connecting to his web server. Now, if his web server has an exploitable service, let's say it's an old web server and there are known exploits, I can then exploit his machine and do the same thing the other way around, just so that he opened me his gate. Thank you for listening. This video was brought to you by Max Kossetz from cybersec at cybersecteam.org.